Hi there, this is Ana Morales and I'm a PhD student at EPFL. And today, before I start, I'd like to ask you guys a question. Which do you think is the most produced material in the world? I'll tell you, it's cement. We produce so much of it that in the end, the CO2 emissions from cement arise to 5 to 10% of the CO2 emissions worldwide of anything that we produce. So what we try to do is substituting part of the cement in the final mix by other materials that do not produce CO2. However, this lowers the early strength of the cement. Nevertheless, it's been proven that small amounts of zinc can increase this early strength and then can allow for a higher substitution of the part of cement, so we can put more of these materials which are more environmentally friendly. But how does that work? What is zinc exactly doing in a cementitious sample, and what is its role in making this early strength better? I don't know, that's why I'm doing a PhD. So the basic idea of my work is answering this question. Where is zinc placed in a CSH structure and what is its role? CSH stands for calcium silicate hydrate, and it's a very important phase in cement that constitutes approximately 60% of its volume. CSH looks like this. It's a layered structure with silicon tetrahedrons and calcium ions. And in this structure, we can discern two types of silicates, what we call Q1 sites and Q2 sites. What I do is I synthesize CSH in the lab in a very controlled setup so that my system is as simple as possible. I analyze my samples first with TEM. This is the so-called Nanofoil Morphology. More importantly though, scanning transmission electron microscopy combined with electron dispersive X-rays show that the amount of counts of zinc increases as the sample contains more zinc. This was a fairly good indicative that zinc could be incorporated inside of the CSH structure, although we couldn't be sure because zinc could also be placed on the surface of the grain and not necessarily inside. So in order to determine if zinc is inside of our CSH structure, what we needed to do is Dnp Enhanced Mass Nmr. Here I show you what happens if we run a cross-polarization experiment on samples with different contents of zinc. These spectra are normalized to the Q1 sites, and from here we can see two different trends. When zinc is added, the ratio of Q2 to Q1 sites increases. This could mean that the silicate chains are getting longer. Also, there's a new peak appearing at around -72 ppm. This is a new species that shows up as we are adding zinc. Therefore, zinc is changing the chemical environment of silicates and is incorporated in the structure, which is what we wanted to prove. CSH was synthesized in the lab. We also confirmed that zinc is inside, incorporated in the structure. And all of this allowed us to make a little hypothesis saying that maybe what zinc is doing is making these silicate chains longer. And this is ultimately making the early strength of the cement better. Thanks for listening and see you soon. Where's the button?